Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so we meet again, and in this video, we're going to continue our discussion on chapter 4, topic 4, Conic, lecture 2 of 4, and still with the topic of circles. Okay. Okay, so you may refer to your notes. We're going to look into the intersection of two circles, second line, and everything here. So I'm not going to read all one by one. We strictly look into the content and also examples. Okay, now find intersection points between the intersection of the following circles. Meaning that here, class, when two circles, okay, intersect, okay, with a circle number 1 and circle number 2, so the intersection point, let's say if I put this label as intersection as an A and B, with A the coordinate of x, y, x1, y1, and also B here, which is x2, y2. Okay, we call the coordinate of B x, y, and also A x, y, shared or owned by both of the equation of the circle of C1 and C2. Okay, meaning here, we are going to find out what we call the coordinate of intersection of A and B by putting both of these into one equation. Let's say x squared. Let's say this is circle number 1 and circle number 2. So we come up with a conclusion that is a C1 equal to C2 because the coordinate of x with A and B are both owned by both of the circle here. So then x squared plus y squared minus 10x minus 10y plus 25 equal to okay, and the next equation here, which is x squared plus y squared minus 3x minus 3y plus 4, okay, not equal to 0 then. Okay, I'm sorry then, here. Okay, this equation of C1 here, x squared plus y squared minus 10x minus 10y plus 25 equal to the second equation of C2 here, x squared plus y squared minus 3x minus 3y plus 4. So just imagine that if x squared bring to the side become negative x squared, so then x squared minus x squared, and also here y squared will here become negative, so y squared minus y squared. Okay, now negative 3 bring to this side here, left side become positive 3, so negative 10 plus 3 equal to negative 7x. Okay, and then negative 3 bring to the side become positive, so negative 10y plus 3y minus 7y, and 24 being here become negative, so 25 minus 4 plus 21 equal to 0. Okay, so then now let's say if I come up with this negative 7x equal to 7y minus 21, and then divide by negative 7 left and right, so negative 7 divided by negative 7, x, 7 divided by negative 7, negative y, negative 21 divided by negative 7 plus 3. Okay, so then x equal to negative y plus 3. So imagine that is equation number 1. Okay, so now this x, negative y plus 3, we may substitute into equation 1 or equation 2. It's all up to you because we're going to find out what is the value of x. if we substitute in this equation of C2 here, okay, equation 1 substitute into an equation of circle number 2, so x remain as an x square plus x, oh no, okay, x equal to negative y plus 3, which is x here, negative y plus 3 square plus y square minus 3 and x, which is negative y plus 3 minus 3y plus 4 equal to 0. Okay, let's expand this one here now. Negative y plus 3 in bracket square means that negative y times negative y, y square. Negative y times 3, negative 3y, another negative 3y, negative 6y, plus 9, plus y square. Negative 3 times negative 9, positive 3y, negative 3 times 3, negative 9, minus 3y, plus 4, equal to 0. So then next, y square plus y square, 2y square, negative 6y plus 3y, negative 6 plus 3 equal to negative 3y, and negative 3y minus 3y, negative 6y. Okay, 9 minus 9 equal to 0, then we get 4 here, plus 4. Okay, so divide by 2 everything here, come up with y squared minus 3y plus 2 equal to 0. So guys, next, factorize this. We are going to find out, we will get what is the value of y here, y and y. Okay, 2 multiplication of two numbers, sum of product of root. 2 is 1 times 2. So negative 3 here, we can come up with negative y, negative 1, negative 2. Y times y, y squared. Y times negative 2, negative 2y, with negative y, negative 3y. Negative 1 times negative 2 equal to 2. Meaning, the value of y here, which is 1, and y equal to 2. Okay class, this is not the final answer because we are going to find the intersection point. Points means the coordinate of A, which is x and y. So right now, we are both getting y1 and y2 here. So to find the value of x, okay, so using the value of y here, y1, when y equal to 1, okay, you may use this value, this equation here, equation 1. This is circle 1, circle 2, and equation 1 here. So then x equal to negative, y equal to 1, 1 plus 3, that is equal to 2. So it means that the coordinate here, which is 2 and 1. This is the coordinate of, let's say, according to this, my picture here, which is a coordinate we call A. And when y equal to 2, then x equal to negative, and y equal to 2. 2 plus 3 equal to 1. So then b equal to x equal to 1, then y equal to 2. There you go. So that is the both of the intersection point between the circles, which is I label this one as an A here and also B here. And now the intersection point, intersection of a circle and a line. Just now we discussed that when two circles intersect each other. Right now when there's a circle and there's a straight line intersect here at the point of A and B. And again, the coordinate of A, which is x1, y1, and x2, y2. So when these two functions of linear and circle intersect each other, meaning that the x and y of A, x, y of B owned or shared by both of these functions of circle and a straight line. So what can we do here now is we can, from y equal to x plus 3, this is an equation 1 and this is an equation 2. So if I make an instruction of equation 2, substitute into an equation 1. Okay, y equal to x plus 3. So every single y that you see here, we're going to replace with 2x plus 3. So x squared minus 2x plus y. Y squared means that y here is squared minus 4 times y equal to 0. And we substitute the y with the equation of 2x plus 3 and another of 2x plus 3. So x squared minus 2x. 2x plus 3 in bracket squared, 2x times 2x, 4x squared. 2x times 3 equal to 6x, with another of 6x, 12x, and 3 times 3 equal to 9. Negative 4 times 2x, negative 8x, negative 4 times 3, minus 12 equal to 0. Okay, so now let's simplify this. X squared plus 4x squared, 5x squared. Negative 2 minus 8, negative 10. X, negative 10x plus 12x plus 2x. And 9 minus 12 minus 3 here equal to 0. Okay, so class is we call quadratic equation here right now. So let's use this. If possible, 5x and x. Because for x times x to get 5, there's no other the choices that you can have, only 5 times 1 or 1 times 5. Okay, and then product of root, which is 3 or negative 3 here. Okay, so do you have any idea? 5 times 1 equal to 5. 5 times 5, 5x squared. 5x times 5, 1 equal to 5x minus 2. Okay, let's try again. 5x times x, 5x squared. 5x times 1, 5x. Negative 2 times x minus 2x. Okay, it's supposed to be 3 here. Get it? 5x times x, 5x squared. 5x times 1 equal to 5x. Negative 3 times x minus 3x. And negative 3 times 1 equal to negative 3. So 5x minus 3x, 2x. There you go. So 5x squared plus 2x minus 3. Okay. I do hope all of you still remember what the idea on how we're going to tackle this. Okay. 5x with 5x squared means that mostly we look at the quadratic equation with a we call coefficient of x squared, which is equal to 1. But right now it is 5. 5, we have no other choices. We only have 5x times x to get 5x squared. But then, for this negative 3, we also only have one choices of a product of root, which is 1 multiplied with 3. Is either -1 here or -3 here, either one. Okay, so we have to play try and error with 5x, then with -3 here, -3 times 1, or might be 3 times -1. So then you may test by yourself. Or let's say if I spend a few times here, if this is 5x squared plus 2x minus 3. Okay, according to this one here, which a the coefficient of x squared equal to 5, b equal to 2, and c equal to -3. Never mind. So then x equal to plus minus b, 2, and negative b, sorry. The formula of this, which is negative b, which is -2 here, plus minus square root of b squared, 2 squared minus 4, a which is 5, and c equal to -3, divided by 2a, where a equal to 5. Okay, -2. Okay, -2 plus minus square root of 2 squared equal to 4, negative times negative, positive, 4 times 5 equal to 20, 20 times 3 equal to 60, divided by 2 times 5 equal to 10. So then -2 plus minus square root of 60 times 4 equal to 64, divided by 10. Okay, so now square root of 64, 8 times 8 equal to 64. So square root of 64, which is square root of 8 times 8, it is -2 plus minus square root of, not square root anymore. Okay. Square root of 64, which is 8 divided by 10. So -2 plus 8 divided by 10, or -2 minus 8 divided by 10. Okay, from here now, we come up with conclusion that 5x minus 3 equal to 0, x plus 1 equal to 0, then x equal to -3 divided by 5, 3 over 5, and x equal to -1. Okay, you may test. Hopefully that you will get both of these answers exactly the same as this one. Okay, never mind. I'm going to clear all this again, because okay, in this video you may compare which method that we call you suitable with. Class, if this kind of question appear, yes, you may have in your mind that why don't we just use the use the calculator to straightly get the answer then. Yes, in matriculation or PSPM, we are not bothered about the final answer. We do really care about the working solution step by step, because every single step is a marks. Okay, if you give the final correct answer without proper or without any working solution at all, we consider as incorrect, or everything is incorrect, and you get 0. So please, okay, I'm sharing you both of this method. If you can't think of how you to find these two until you get the answers here, you may use the formula. So it's up to you then. I'm sharing both, then you decide. Okay. And now, find the intersection points. Find the points of intersection, meaning that the coordinate of A and B for these two, the line and also the circle. So I already got the both of x, 3 over 5, and -1. So then, when x equal to 3 over 5, you may choose either equation of circle or equation of straight line. It's all up to you then. But why must we make our life hard, right? choose the, we call the simplest one. You can choose equation 2 of the straight line here. So that y equal to 2 times x, 3 over 5 plus 3. Okay, so from here, you may recall 2 times 3 equal to 6 over 5 plus 3. Change in the form we call a fraction over 5 here. 3 times 5 equal to 15 over 5. 15 divided by 5, 3, that's it. 15 over 5, and you get here 6 plus 15, 21 divided by 5. So then the first, okay, I label this here as an A and B. So then A with a, we call the intersection, the first intersection point, which is x equal to 3 over 5 and y equal to 21 over 5. And then when x equal to -1 here, substitute here, then y equal to 2 times -1 plus 3. So -2 plus 3 equal to 1. So then B, the next coordinate, which is -1 and 1. There you go. Okay, next. Now, distance between a point to a line. Okay, so just imagine that this is one of a straight line of L in the form of ax plus by plus c equal to 0. Then we get one of the point of P, H, and K here. Okay, we find the nearest distance between the point and the straight line. So then, the distance of this equal to D, okay, according to, we call the formula here. Make sure that this straight line we come up with a form of ax plus by plus c equal to 0. If the question gave you in the form of y equal to mx plus c, so change everything into this form where x and y on the same side here equal to 0. Okay. Wait a minute. I think that okay, class, I don't realize that might be that I recall I delete the question example for this part. Okay, never mind. The question is, okay, example 3. Okay, I rewrite all everything again. Find the general equation of the circle that satisfy the given condition. Okay, the center, which is 0 and 7, touch the line of 3x 3x equal to 32 plus 4y. Okay, now just imagine that the center of the circle is a point. According to this, just imagine that the P is the center of the circle, and P here, okay, between a point and to a line. This point is the center of the circle, that we can imagine that there is a circle here, and the distance considered as the radius between the center and the point of Q here. Okay, so then now, okay, and sorry, okay, so this is 3x minus 4y minus 32 equal to 0. Again, please refer to the notes. We want it in the form of ax plus by plus c equal to 0. And get here now. Okay. And the point of touch between the circle and the straight line. And according to the notes before, this P is the center here. And the center which is 0 and 7. Sorry again. And form the 90 degree here. Okay. So now the radius between this center to this point of, let's say I name this one as a P here, from C to P, which is a radius of, okay, what is the formula given just now? AH plus BK plus C. AH plus BK plus C, which means that with the A here equal to 3, B negative 4, C negative 32, H equal to 0, and K equal to 7. So now, A and H, A 3 times 0, okay, 3 times 0, plus B, B and K, negative 4 with 7, and minus 32 divided by square root of A square plus B square, where A equal to 3, 3 square plus B equal to negative 4 square. Okay, so simplify this and you get is equal to 12. So the radius or distance from this point to this point here equal to 12, and the equation of circle, x minus h square plus y minus k square equal to r square, where h equal to 0, x minus 0 square plus y minus k equal to 7 square equal to r 12 square. So then x square plus y square minus y with 7, negative 14y plus 49, and then this is 12 square is 144. Bring this to the left side, it minus 144 equal to 0. Then you get here x square plus y square minus 14y minus 95 equal to 0. Okay. So position of two circles. So in this explanation, you see when two circles, okay, we can consider that the circles that might be they intersect each other, or might be one of the circle is smaller than the other one, so the smallest might be inside, okay, inside and touch one of the point of the circle from outside, from inside, or touch the circle from outside. Okay, so now might we look into the numerical expression one by one. So let's see C1, C2 be centers of two circles and radius R1, R2, radius of the two circles here. So when two circles each other externally, B1 and B2, okay, externally means that both circles not okay. both of circle is not inside each other, then so one we call the smallest is not inside the biggest one, but it's outside, so they touch externally from outside here. Okay, so this is the point of intersection. So we call the radius of C1 and R1, the center of C2, and also the radius for the circle number 2, R2. So R1 plus R2 is the distance from the center 1 and center 2 here. Okay, C1 and C2 equal to distance between C1 and C2, and is also additional of the radius of R1 with R2. Okay, next, internally, B1 here, there you go. The first circle number 1, smaller than the circle number 2, and they touch internally, inside, from inside here. Okay, so the distance between C1 and C2 is the we call modulus of R1 minus R2. Okay, we'll see how. This is C1 and C2. Okay. The radius of R1 means that the radius from this point of center to this line, okay, to this point, which is longer than the radius of R2 from C2, from this point center to this point here. Okay. And when two circles do not touch or cut each other externally. Okay. And then here. Okay. So then, we call the distance from center 1 to center 2 here. It's the distance between C1 and C2. Okay. Is greater than R1 plus R2. Okay. And internally, there you go. One small circle inside one of the big circle here, and did not touch at all, just floating inside B1 and B2. So distance between C1 and C2, okay, might be the distance of the center of C1 here, and the center of B2 somewhere around here. So the distance C1, and this is center of, we call the radius 1 and radius 2. So the distance between C1 and C2, it might be less than the radius of R1 minus R2. Okay, you can just imagine that in any situation might be this circle somewhere around here, not very centric to this big circle. So when the two circles cut each other, then C1 and C2, okay, so then the distance between C1 and C2 equal to the distance between center 1 and RC2, which might be less than of R1 plus R2. Okay, with a few examples, and you try a few exercises, then you can see the idea of all this. But you can also predict from these pictures to see the distance from the center to the center and compare with the radius between both of the circles. Okay, Example 4, given the circles of B1 and B2, find the centers and radius of the both circles and hence show that these two circles do not touch each other. Okay, so for this example, okay, let's copy out both of the equation of circle given in the example just now. With B1, okay, it is x squared plus y squared minus 10x plus 18y plus 70 equal to 0. Okay, the first circle B1. And B2, here is x squared plus y squared minus 6y minus 7 equal to 0. Okay, let's compare both of these. We call circles with x squared plus y squared plus 2gx plus 2fy plus c equal to 0. Okay, for B1, once we compare this with this general equation here, then you get 2g equal to negative 10. 2f equal to 18 and c equal to 70. So then g equal to negative 5 and f equal to 18 divided by 2 equal to 9. So then the center of this circle for B1, the center which is 5 and negative 9, because the center, when we call this then as a F and G, H and K, E also equal to, according to this one here, is negative G and negative F. Okay, so the center of the circle is 5 and negative 9. And the C is 70. Where for B2, so then there's no x, it's only x squared here, there's no x. So then x equal to g equal to 0. Okay, to g equal to 0, to f equal to negative 6, and c equal to negative 7. So then g equal to 0, f equal to negative 3, c negative 7. So the center of this is 0 and 3 here. Okay, now the radius of B1, equal to square root of so we call the radius of B1 here, which is g square, which is negative 5 square, negative 5 square here, which is equal to 25, and then f square equal to 9 square equal to 81 minus c equal to 70. Okay, so then here now 25 plus 81 minus 70 equal to square root of 36, and is equal, the radius is 6. And the radius of B2, okay, g square equal to 0 plus f square equal to negative 3 square equal to 9 minus negative 7. Okay, 0 plus 9, negative become positive, square root of 16, which is equal to 4. So the distance of center between both of the center of the circle. So the distance of circle, both circles with C1 and C2 here equal to the center between this and this. Square root of 5 minus 0 squared plus with negative 9 minus 3 squared. And you count by yourself, this is going to give you square root of, oh no, square root of 13, it's just 13. So now guys, girls, let's compare the distance of the two center of the circles equal to 13 here, and radius of B1 plus the radius of center of B2, 6 plus 4. 6 plus 4, which is equal to 10. Okay, so if both of the circle touch at one point, means that the circle touch something like this. Okay, so the center and the center of here and radius, another radius. So we call the distance from center 1 and center 2 is also equal to the radius of 1 plus width R2. Okay, but it's not happening because similar to this case, because the center of the circle C1 and C2 is greater than the addition of radius of B1 and radius of B2, meaning here C1 and C2 is greater than R1 plus R2. So we come up with a conclusion: the circles do not touch each other. Okay, so that is the conclusion then. Okay, use it. You may also use the discriminant of this. Might you recall? Hopefully that you still remember this. The thing that been taught to all of you from Form 4 and Form 5 using all this. Okay. So let's continue with the next one here. The discriminant of the quadratic equation formed by eliminating y from the equation of a straight line and circle tells us how the line and circle are related. Okay, touch at one point at tangent. So touch one point at tangent here, b squared minus 4ac, when the one line touch at one point here, and this is called a tangent of the circle. With the blue one here for b squared minus 4ac, when it cut at 2 points here, 1 and 2. So b squared minus 4ac greater than 0. And here did not touch the line, did not touch the circle at all. So it is b squared minus 4ac less than 0. Okay. Given a line of this, line of y, x minus 1, and circles, show that a circle and line never meet. Okay, from here, we substitute. Okay, so from this line and the circle given here, so we substitute the line of y equal to x minus 1, substitute into the circle's equation of circle here, x plus 2 squared plus y minus 1 squared equal to 4. Okay, so x plus 2 squared plus y equal to x minus 1. Means that here substitute y, replace y with x minus 1. X minus 1 minus 1 square equal to 4. X plus 2 square plus x minus negative 1 minus 1, negative 2 minus 2. X minus 2 square equal to 4. Okay, so expand this one here now. X square plus 4x plus 4 plus x square, x times negative 2x, another negative 2x, negative 4x times positive minus 4x, negative square, negative 2 times negative 2, positive 4. And bring it here, minus 4 equal to 0. X square plus x square, 2x square, 4x minus 4x, okay, 4 minus 4 and plus 4 equal to 0. Okay, let's compare with ax square plus bx, plus bx plus c equal to 0. So when you compare this with this one here, now we come up with a equal to 2, b equal to 0, and c equal to 4. Okay, so using b square minus 4ac, which is b square 0 square minus 4a equal to 2 and c equal to 4. Okay, 4 times 4, 4 times 2 times 4 equal to negative 32, which is less than 0. So since that b square minus 4ac is less than 0, therefore the circle and the line never meet or do not touch each other. Okay, example 5. Equation of tangent and normal to a circle. Okay, class, from this coordinate, we call the center of the circle. Okay, and also you can see there's a straight line here touch at one point of the ring of the circle. Okay, so it formed the 90 degree between the line of normal and line of tangent. So this is y equal to mx plus c, where m is a grade, for this one is a gradient of normal, and this is y equal to mx plus c, and the gradient of m for this is the gradient of tangent. And multiplication between the gradient of tangent multiplied with the gradient of normal times negative tangent equal to negative 1. Find the equation of tangent and normal of the circle at the point of 3, 1. Okay, so we are going to class for this circle. Okay, just imagine there is a circle here and there is a center. So find the equation of tangent and normal at the point of 3, 1. Just imagine there is a point of 3, 1 here. So now, well, it's that we call the sketch is very small here. Okay, the circle. There is a, we call the center of the circle and one of the coordinate of this point here. There you go. Okay, so just imagine that there is a, we call a line that forms a 90 degree, sorry for that. Okay, something like that. Okay, it touched at this point here, and between this line and this line form the 90 degree. Okay, so this is the equation line of tangent. Y equal to m t x plus c, m x plus c. This is a gradient of tangent, and this is y equal to m x plus c, where this is a gradient of normal. Okay, so now how we find out the gradient of tangent and normal here? We need to find the center, and we are going to compare. We call to find the gradient of tangent and normal to find the distance between these 3 points of 3, 1 and the center. So we compare this with x squared plus y squared minus 8x plus 6y plus 8 equal to 0. We compare with x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So from here, 2g equal to negative 8, 2f equal to 6, and c equal to 8. So then, g equal to negative 8 divided by 2, negative 4, f 6 divided by 2 equal to 3. So then the center here is 4 and negative 3. So the center 4 and negative 3, and this point of 3, 1. So the gradient between C and this one here is a gradient of normal. Okay, gradient of normal. Take this one, negative 3, and here is the coordinate of 3, 1. This is 3, 1. Negative 3 minus 1. And 4 minus 3. Okay. Gradient of normal, negative 3 minus 1, negative 4. 4 minus 1 equal to, 4 minus 3 equal to 1. Okay. 4 minus 3 equal to 1, which is negative 4. Okay. Negative 4. So the gradient of tangent, and of course gradient of tangent times gradient of normal equal to negative 1. So when gradient of normal is negative 4, the gradient of tangent is negative 1 divided by negative 4 is 1 over 4. Okay, so the equation of normal. Equation of normal, y minus, we call the coordinate of 3 and 1 here, because this is a line passing through the point of 3, 1, y minus 1 equal to negative 4 and x minus 3. And equation of tangent. Equation of tangent, again, the line passing through 3 and 1. And you may also use this one here because the tangent, wait. The equation of normal, yes, this is the line. Okay, y minus 1 equal to negative 4 and x minus 3. Equation of tangent, you can only use this one here. Okay, so y minus 1 equal to 1 over 4 and x minus 3. So simplify this and simplify this, and here you should get, okay, equation of tangent, here you should get y equal to 1 over 4x minus 3 over 1 over 4x minus plus 1 over 4. And for the equation of normal, y minus 1 equal to negative 4 times x minus 3. Then here should you get y equal to negative 4x plus 30. Okay, that's it. The solution for this question here now. Okay, the length of a tangent from the point to the circle. So let's see the length of a tangent from the fixed point of P to a circle with the equation of, here the equation of circle can be found using the diagram and the Pythagoras theorem. And the distance of P to Q. P to Q is the distance of this one here. Okay, so just imagine that if I put this one here as an A, C to P as an A. Okay, so this is Pythagoras. We call the circle with triangle with a 90 degree of this. Okay. Okay, it's something like call R square plus D square equal to the pi, we call the hypotenuse, which is A square. So then D square from Q to P equal to A square minus R square. Then D equal to square root of A square minus R square. Okay, so we call actually that this is the this one is the explanation of above here. Okay, CP square minus CQ square. Okay, so now we compare this with the x square plus y square minus 2gx minus 2fy plus c equal to 0. So then 2g or plus, sorry, 2g equal to negative 2 and 2f equal to negative 8, c equal to negative 8. So then g equal to negative 1, f equal to negative 4, and c equal to negative 8. Okay, so then now, let's say this is the circle, and this is the straight line, touch at one point. So this is the center, okay, and there is a coordinate of A here. So this is the radius, and also this is the distance from the R to the point of A here. And this gives, we call the form of 90 degree. Okay, so at the point of 6, 7, A, which is 6 and 7 here, so then the center of this circle here is 1 and 4. The center is 1 and 4. Okay, so then just imagine that if I put this center as a C, here as a Q, and this is A. Okay, so CQ from C to Q equal to the distance of radius here, which is G square. G is negative 1, so negative 1 square is 1. Negative 1 square is 1. Okay. G square, negative 1 square is 1, plus negative 4 square equal to 16 minus negative 8. Okay, so negative times negative become positive. So 16 plus 8 is 24, plus 1, 25. Square root of 25, 5. Okay, and the distance of CA, C to A, from center to the point of A here, square root of the center is 1. Okay, center of A to C, 6 minus 1, okay, never mind, 6 minus 1 square plus 7 minus 4 square, and is equal to square root of 34. Okay, you may just count out by yourself. And I just straightly give you the answers here, square root of 34. So then, A to Q. This is the D that we're looking for here now. Okay, the D from this Q to AQ. And it is square root of square root of 34 square here, and minus minus 5 square. And this equal to square root of 9, which is equal to 3. Okay. Okay, class. So I think that is the last final example for this topic. So you may try with the exercise here to see whether the circle and the straight line cross or touch or never meet the circle. Okay. So that's all. Thank you very much. And till we meet again, Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.